Welcome back. This is Randy Pryor, UNL Extension Educator in Saline County. This lesson, our last lesson, is for the Nebraska 4-H Corn Challenge Sustainability Award participants. This is a fun one because we can learn how to do the last 4 steps and then get to calculate our first field print for our corn challenge field. So to do that, use our favorite browser, and we'll type in www.fieldtomarket.org and click on the link Fieldprint Calculator. Bottom of the page, there's our calculator login tab, and we'll go ahead and log in. This particular browser saved the criteria that I needed. So I'm going to go ahead and load my saved field from past entries called the 4-H Challenge field in Wilbur. This time the loading is taking a little bit longer. There's a reason for that. I've turned on the WEPS model, the Wind Erosion Prediction System, WEPS, and I've changed my mind on that. I would like all the challenge participants to now turn on the WEPS model execution. Wind erosion in eastern Nebraska is usually a minor factor, but nevertheless, there's a small number there. And who knows, that small number might be the tiebreaker between one of our teams. So I've changed my mind. Sorry about that in a comment in a previous lesson. But now calculations are almost done, so we can go ahead and hit yes and save WEPS. After doing that, we will scroll down and we are finished with management. We have 4 activities left. These 4 activities don't take very long. They're self-explaining, and we'll start with product transportation and hauling. Yours will say for the 2015 crop, even though my example says 2014. From my field to the marketplace, to the elevator where the grain's going to be marketed, it's 13 miles. And so this is one way, one load. If you look at the help message, it's confusing. It says if more than one trip is required, each trip should be added. We don't do that. That needs to be corrected on the help messages. So at this time, it's from the field to the marketplace. Now, what if it went to the grain bin? Well, calculate the number of miles from the field for where the challenge plot is located to your grain bin, and then from the grain bin to where the grain is going to be marketed. The total miles, one trip, one load. Fuel type, oftentimes that's going to be diesel fuel. But in Nebraska, oftentimes we will be using biodiesel. If you know that it's B5 or B20, you can click on that. Most of our diesel fuel has some soybean oil in there and reduced sulfur and increase lubricity for your engine, and I'm going to click on biodiesel. So we're done with that section, and now I can hit save. Under drying, if you didn't dry at all, you could click on no drying system used. That should be your default, and hit save. But in my case, let's say it went to the bin and we had an aeration fan. Didn't dry it with continuous flow or batch in bin or low temperature drying, but let's say we had an aeration fan. This is how you would do that. In bin, natural air only, and usually that can remove a half to 1 point over time. In this case, I'm going to remove a half a point of moisture. If I knew what the electrical use was of that electric fan, I could put the actual records in there, and it would make it even an improved calculation. Or if there was drying done in bin with propane or natural gas and you knew the fuel, you can actually improve the calculation. And then go ahead and hit save. Looks like I have an error message. Sometimes I do make a mistake, and it says I did not specify an energy source. Yes, that is correct. I should have specified diesel, electric grid, solar, wind. In this case, it was aeration fan is run off of an electric motor off the grid. Now I should be able to save. With that, we go to the planted but not harvested area. This is just a placeholder right now. It's not really used in any Fieldprint calculation. Area of the field, area that you planted, area that you harvested. Is there a difference between planted and harvested? There could be, and there could be a good reason for that. If there was a flood or a drought or some other natural disaster or damage to the field, or even that herd of deer that wiped out an acre on the end of the field. Well, if that happened, you can go ahead and calculate the difference and put the reason. And in my field, we harvested everything that we planted, so I'm going to go ahead and hit save. And finally, we hit conservation practices. If you have a buffer strip in your field between the creek and that goes right alongside your field, and if there was a buffer strip right here, and this was a creek on the east side, you can go ahead and hit filter strip. Or if there was a grassed waterway in this field, this is a grassed waterway here, you can go ahead and click on grass waterway. If you have any water and sediment control basins, in other words, mini terraces to stop a gully, you can go ahead and click on water and sediment control basins. This sediment basin here is used for a different practice that would not typically be used in a farm field. It's a little bit confusing there for purposes of our project here. If you have sediment control basins, use this one. Some other conservation practices listed here. You can list up to 3. If you have any at all, go ahead and click on those. So with that, I will hit the final save button, and that makes me feel good, finished with all the data. And now we can hit calculate. This will be our first field print for this particular field. In Nebraska, you truly are some of the first 4-H'ers in the state that have ever done this, along with your parents, benchmarking 7 different criteria. On the right, you can see national average, state, county based scenarios. These benchmarks, you'll only be able to compare right now with national and state benchmarks. The default is state. That would be in the orange. And notice that my field, I've beat every one of those state benchmarks. So that's really good. You want to be, this is a slider bar. It's an index from 0 to 100. You want to be as close to 0 as possible. Nobody's ever going to hit 0, but you want that to be a low number. So let's go and look at the spidergram. The national benchmarks are in the green. The state benchmarks are in the orange, although there's no benchmark for water quality index yet in Nebraska for a state benchmark. The spidergram in the center is my field print. 4-H challenge plot field that has the smallest footprint around the 0 mark is going to win the $200 this year for this contest. Let's look at what each one means, what each one really means. Land use is the opposite of yield per acre. It's the number of acres to produce a yield. So it's acres per bushel. the inverse. So over your area, if you had a really high yield, that number is going to be a lower number, and that's what we want. Although it needs to be profitable too to attain that yield. Notice in the tabs up above, you can all look at each individual number. I'll click on land use here. It takes a little while to calculate with each tab, but you'll actually see that number, and it's going to be a really small number. The state number is 0.005. My field, I just barely beat it. It was 0.00465. Economic analysis tab, I mentioned about the profitable yield. That needs a lot of help, and so that's an area there would need to be future improvements on with the Fieldprint Calculator. At this time, we haven't put any economics into the tool. We'll go back to the summary spidergram, and the next thing we're going to look at is soil conservation. Soil conservation will have water and wind erosion numbers associated with it. Over on the slider bar on the right-hand side, there's also a black T. That's your soil's tolerable loss as defined by the NRCS in tons per acre per year. So that T value, you certainly want a goal of being under T. T still permits a high level of crop productivity to be sustained economically and indefinitely over time. And farmers continue to improve and reduce soil erosion loss on their farm fields. And we would like to see this number under T if possible. Soil carbon. This isn't a direct measure of soil carbon, but it's an index called Soil Conditioning Index. It's from the NRCS, and it's defined from a -1 to a +1. A -1 would be not good. A +1 would be very good. If the number is -0.05 or +0.05, around 0, that's considered neutral. So if you have a number of 0.5 or 0.6 or 0.7, that's pretty good. That means you're moving in a positive direction. Soil carbon is related to soil organic matter. Soil organic matter can improve water infiltration of your soils. It can improve water holding capacity and water and nutrient holding capacity, increases crop yield, and it's involved in a lot of important soil health properties. So the higher that SCI number, the better. Irrigation water use. This is the amount of bushels that you increased over your dryland yield. So it looks at your productivity over the dryland yield and then how much irrigation water that took. So it's acre inches of water applied per bushel of additional production that you experienced. Greenhouse gas emissions. Greenhouse gases warm the earth, and CO2 and NOx or NO2 emissions are implicated as greenhouse gases. So the lower the number, the better to produce food. So greenhouse gas is directly related to energy use in farming. So the greenhouse gas is the amount of greenhouse gas that's emitted to produce corn seed, to produce the fertilizer. Lime is not included in the tool at this time. And it's also the amount of greenhouse gas embedded into produce crop protectants that we use. To apply these products to the farm field, these calculations are direct calculations are also made. So we would like to see that as low as possible. One of the fallbacks here with both energy use and greenhouse gas use in Nebraska, we are a large irrigated state. These metrics do not parse out separately dry land and irrigated benchmarks. It's a weighted yield between the two. So I wouldn't pay too much attention to these benchmarks here and here until those are improved. You basically need to improve on your own over time if you can. The water quality index is an index used by NRCS, and you want that as low a number as possible. And it goes from 1 to 10. So 10 would mean really good water quality as far as field runoff criteria, and 1 would be poor water quality as far as field runoff with nutrients going off the field. And so right now, there's a lot of debate about this particular index. It's the best we have at this time. Look for future improvements with the WQI. So there we have it. You can explore each of the tabs up above and look at the individual numbers. You can explore the state national averages. Just remember, the entire food chain is looking at this Fieldprint Calculator tool at this time. Some of your farms may be asked to participate and provide information about your field print when producing food. In the future, fortunately, some companies are already paying a premium to get additional information because it has marketing implications for food companies in the future when we increase our efficiency at the farm level. But when we increase our efficiency and we increase things that help the environment, usually that's also directly tied into increased profit. Not always, but it can. And so you truly have established the first field print benchmarks for your farm. I see this tool being improved all the time. Nebraska Extension is now a member of Field to Market, and we have staff that are looking at how this tool can be improved over time to the benefit of Nebraska farmers. Good luck in your contest. We will see who wins the Nebraska Sustainability Award contest using the Fieldprint tool this year when we go to that banquet, which I believe will be in January of 2016. So long. If you have any questions, sure let me know.